Hi, welcome to Lab 15, Testing Security Policies with Packet Tracer. Packet Tracer is a tool within ASDM that gives you a graphical representation of the firewall and its internals. You can watch a virtual packet as it passes through the firewall, and you can see if it's permitted or denied each step along the way. That way you can verify this with a virtual packet without sending real packet or real traffic through the firewall. So let's get started. We'll begin this lab with a firewall configuration that was completed as part of Lab 14. As you know, the configurations build on each other from one lab to the next, so we're not going to make any configuration changes here. Instead, we're going to go straight to the Packet Tracer tool. To do that, we go to the top of the ASDM window, click on Tools, Packet Tracer, and a new window comes up for the Packet Tracer. Now, this window is slightly larger than the video window that you're viewing, but the only thing missing are the title bar and two buttons at the bottom, Close and Help. We won't need those buttons for this lab demonstration, so what you're seeing will be just fine. It's really easy to use Packet Tracer. Let's briefly go over this window and its options. The idea behind Packet Tracer is to send one packet from one interface all the way through each of the security policy modules within the firewall until the packet exits a second interface. So first you choose the ingress interface, or where the packet enters the firewall. This can be any interface that's been configured, such as the inside. Next you choose the packet type. You can select TCP, UDP, ICMP, or IP. Based on the packet type, you select the options that will be present within the IP or the protocol header. Toward the middle of the window is a graphical representation of the internal firewall modules. In the initial window, we see modules that are titled Route Lookup, Access List Lookup, NAT Lookup, and so on. These modules will change based on the type of packet and the source and destination you set up, as well as the firewall configuration. For example, here's a module called VPN Lookup. In our scenarios, we won't be using VPN at all, so that module will disappear, and it'll be replaced by more appropriate modules. And we'll see that as we move through each scenario. For our first scenario, let's choose a simple setup. We're going to use an ICMP packet that starts on the inside interface. We'll choose a source address that's present on the inside of the firewall, and a destination that's present on the outside. Next, we're going to choose our ICMP type. This is going to be an echo packet. Our code will be 0, and the ID will be 1024. Next, we click on the Start button to start the packet's journey through the firewall, and we'll get to watch the journey play out in the picture below. So we'll click on Start. Now you see the packet moving through Flow Lookup, Route Lookup, Access List Lookup, IP Options Lookup. Here's an inspection engine, another inspection engine, a NAT Lookup, another NAT Lookup, IP Options Lookup, Flow Creation, and finally the packet has arrived on the outside interface. And that took place exactly as we expected. It went from the inside to the outside. Now at the bottom of this window, we can see the results of the packet's journey. Here are each of the modules presented in sequence. These are labeled as phase. You can click on the plus sign just to the left of each module to see what the module is and what happened. For example, the first module is Flow Lookup. The firewall was looking for an existing traffic flow present in its connection table. It didn't find one, so it created a new one. At the very bottom of this section is the final result. Here, the packet is allowed. So the firewall didn't drop the packet, it forwarded it from the inside interface to the outside interface. There are a couple of things we can see from this example. First, we can look in the inspection engine section, and we can see that the inspection type was ICMP. So the firewall has figured out that this is an ICMP packet, and it's passed it to the ICMP inspection engine. Secondly, if we look at the NAT results, we see that the type of NAT was a static. Our source address was 192.168.2.99, which is mapped to 100.99. Now let's do a second example. We can either click the Clear button to clear all the entries, or we can go through and edit each one. This time let's trigger a dynamic NAT address translation. So we're going to go from the inside interface again. We're going to choose ICMP. This time we're just going to change the source address to 192.168.2.50. That falls within a pool that will trigger dynamic NAT, and our outside address will be the same as before. We'll choose another echo packet. Code is 0, ID 1024. We'll click Start, and notice each time we click Start, Packet Tracer spends a minute getting the latest configuration from the firewall. That way you can go back to the ASDM window and make configuration changes, and come back to the Packet Tracer window, and you'll always have the latest results. Alright, this time the packet passed again, and the difference here, if we look in the NAT section, this time it's not only shown us that it's a dynamic NAT, it's also told us which NAT configuration we're using. This is NAT on the inside interface, ID 3, and it's showing how the dynamic NAT has taken place. Here's the translation to pool 3, and it shows the address range within the pool. So the end result is shown below. There's a dynamic translation from 2.50 to 100.26. In our next example, let's clear everything. We're going to look at a packet coming from the outside toward the inside, so it'll be inbound. So we'll select the outside interface this time. And let's do another ICMP packet. But this time we're going to choose an echo reply. This is as if a host on the outside has sent an echo reply toward a host on the inside. So our source address will be 198.133.219.25. The destination will be 100.99, which is an address that's present on the outside interface of the firewall. And there's a static translation that maps 100.99 to 192.168.2.99 on the inside. Here we're going to pick echo reply, code of 0, ID 1024. Click start. Now notice how the graphic representation has changed. There are only 3 modules shown. There's a flow lookup, there's an unnat lookup. This is where the address translation is undone or unraveled, and an access list lookup. The end result is that the packet is dropped. So here's a clue to why the packet was dropped. The flow is denied by a configured rule, or an access list. And over on the right side, notice we have green check marks for flow lookup and unnat. That means those modules were passed, or the packet was forwarded. The next one, with the red X, the packet was dropped. So we can begin here and expand access list. And we see the access list, the implicit rule, or the implicit deny, at the very bottom of the access list, is the one that dropped the packet. Now we can click the link here, Show Rule and Access Rules table, to see exactly which rule caused the problem. If you click that, it just brings you to the ASDM window under Access Rules. Here's the outside interface, and it's highlighted the very last rule, which is the implicit deny any. So let's go back to our packet tracer window. Now this showed that the access rule denied a packet. Something to keep in mind, packet tracer does have some limitations. For example, in our first scenario, we sent an ICMP echo packet from the inside toward the outside. We might expect that a host on the outside would get the echo packet and return an echo reply packet, like we just simulated in this scenario. The one thing that's missing in packet tracer is the stateful analysis. We can only send one packet at a time, so we can't send the initial echo packet and wait for the echo reply packet. We can only send either the echo packet or the echo reply. So we can only see a snapshot of what's happening in these modules based on that one packet. As a final scenario, let's switch over and look at a TCP packet. We're going to simulate sending a TCP packet for port 8080 from the inside toward the outside. Because we're using TCP port 8080, we should see the firewall send that packet to the HTTP inspection engine based on a service policy we configured in Lab 14. So our source address here is 192.168.2.50. Our destination is a host somewhere on the outside. Source port we don't really care about. We're just going to make up something. The destination port is important here. Of course, port 8080 is not a predefined protocol, so we're just going to enter 8080 here. Click the Start button. So far the packet has passed each module. And finally the end result is that the packet is allowed. Now what we're really after are some details about what happened to the packet. We do see in the middle of the flow it did enter an inspection engine. So let's find the inspect section here. Click on the plus sign. Now we see that the packet was sent based on class map HTTP 8080. It matched TCP port 8080. It was sent to policy map outside policies, where it matched class map HTTP 8080, and it entered the HTTP inspection engine. So even though it wasn't a predefined or a default port for HTTP inspection, our service policy handled the packet and it was sent to the right inspection engine. One final thing to note about Packet Tracer. When you simulate a packet traveling through the firewall, Packet Tracer shows the ingress and egress interfaces, but packets don't actually enter or exit those interfaces. So you never see the simulated packet appear on the network. Instead, Packet Tracer places the packet in the queue just inside the ingress interface. The packet actually moves through each module in the firewall, as if it were a real packet received on the wire, and then the packet is removed just prior to arriving on the egress interface. In this lab, we've seen examples of how to use the Packet Tracer tool to watch packets as they pass through the firewall, whether they're permitted by each module or whether they're denied by a module. And all that's been done by sending virtual packets so that you can validate your firewall configuration. In Lab 16, we'll explore ways to capture traffic that's passing in or out of a firewall. That lets you see the actual traffic that's coming or going, and it's a very handy troubleshooting tool.